Hello class. So here is a second numerical on the ladder friction. We have seen in the yesterday or the previous video how we have to take the frictional forces or how we have to consider the forces acting on a ladder. It is a non-concurrent force system. So equations of equilibrium will be 3, Fx, Fy and m equal to 0. So let us go to the next type of problem where the theta, that is angle of inclination, is unknown. So I'll read out and then we'll solve. A ladder weighing 200 Newton, again its entire weight is 200, which should be shown at the center, is supported as shown in the figure. If a man weighing 650 Newton climbs on the top of the ladder, that is at this point, determine the inclination of the ladder, that is theta, with the floor at which the ladder is to be placed to prevent slipping. So what is this angle theta? So that with a man of 650 Newtons weight and its own weight as 200, the ladder should not slip. Okay, take coefficient of friction mu 0.25 for all the contact surfaces. They have not mentioned here about the smooth surface, so we have to consider the frictional forces first. Along with that, they have given us mu, so we know the relationship between mu and frictional force F, mu equal to F by N. So I have to make use of that condition or the relationship and solve the numerical. So first let us draw the free body diagram. So look into the free body diagram. This is your ladder. This is point A, point B. No height is given to us, nor the base is given, but the length of the ladder is given. That is, the length of the ladder is 4 meters. This point A, point B. At A and B, we'll have normal reactions. I've called them NA and NB. And 650 weight person is standing at point B. Apart from that, he says the ladder should not slip. So when the ladder is going to slip, this point moves down. So friction top. So I've shown FB on top. This point moves towards the left when the ladder slips. So friction would be towards the right side. So I've shown the FA force towards the right side. I hope you understood. I'll repeat once again. When the ladder is going to slip down, this point of the ladder moves down and this point of the ladder moves towards the left. So friction should be shown opposite to them. So when the ladder moves down here, the friction FB is upwards. When it moves towards the left, the friction FA is towards the rightwards. So we show normal NA and B. We show FAFB, that is the frictional forces. 200 is the weight of the ladder. 650 is the weight of the man who is standing at the top of the ladder. Okay. The entire length of the ladder is 4. So 200 would be equally divided at 2 meters and 2 meters. They've given us mu 0.25. So we know that mu is F by N from the law of friction. So which can be F by N or FB by NB. I will substitute 0.25 equal to FA by NA and I get the relation FA is 0.25 times of NA. Similarly, FB is 0.25 times of NB. So we know that the equations of equilibrium are 3. So applying the first equation, that is summation f of y equal to 0. Which f of y means all the vertical forces. So which are the vertical forces? NA, 200, 650, FB. Okay. So I will write, I'll make this a bit smaller so that it's visible. So I have plus NA plus FB upwards minus 200 minus 650. I'll write NA as it is. I know FB in terms of NB, that is 0.25 NB. So I'll substitute 0.25 NB and 650 and 200 minus 850. This is equation 1 because I don't know both NA and NB values. Then I'll write summation f of x. FA, two forces, horizontal forces. So FA minus NB equal to 0. I know the value of FA, that is 0.25 times of NA, and NB I'll keep it as it is equal to 0. From this I will get a condition NB is 0.25 times of NA or NA is NB by 0.25. We can make use of these two for the further simplification. I'll substitute any of these in equations 1 to resolve this equation. So what I'm doing is I'm considering NB is 0.25 times of NA in equation 1. So I have NA, that is going to be 0.25 times of, sorry, NA as it is, then NB is 0.25 times of Na. So on substituting in this equation, I get only Na as unknown, and I get the value of Na, that is 800 newtons. Okay, and I'll substitute Na in NB equation. I'll get the value of NB. Once I get Na and NB, that is the normal reactions, I substitute them in Fa and Fp to get the values of Fa and Fp. So Fa is 0.25 times of Na. I substitute, I get the value of Fa. Fp is 2.25 times of Nb. I substitute, I get the value of Fp. Okay, so if you've got Na, Nb, Fa, Fp values with us. Now the third equation of equilibrium is moment. To take moment, I should know the distances, like in previous case, all the horizontal and all the vertical distances. In our present scenario, they have not given us the vertical height, neither the horizontal height. So what we do, draw the triangle, entire base I call it X, entire height I call it Y, and the weight of the ladder is acting at the center. At that junction, the height I call it Y1, and this I call it as X. Okay, I've drawn the same figure here. This must be not clear, so there's another figure over here. So in this particular diagram, if I say cos of theta, theta being obviously here I've not shown theta, here it is clear. Theta, this is theta, angle of inclination. Cos is opposite upon hypotenuse, sorry, adjacent upon hypotenuse. So x by 4, I get the value of x. X is 4 cos of theta. Similarly, sin theta opposite upon hypotenuse, y by 4. So y is 4 sin of theta. Similarly, for the smaller set of triangle, cos of theta, x1 by 2, because this hypotenuse becomes 2, and sine of theta, y1 by 2. So y1 is 2 sine of theta. In this triangle, I will apply cos and sine thetas. I get these two set of values. Okay. Now substitute in summation mb equal to 0. That is moment of all the forces about point B is 0. Whereas point B, this is a point B. I have to take moment at this point. So 650 NB and FP are passing through this. So they all three are 0. I will get moment only because of 200 FA and NA. NA to be in clockwise direction. Perpendicular distance is X. FA goes to be in anti-clockwise direction. Perpendicular distance is going to be Y, its height. And 200 also goes to be in anti-clockwise direction. The perpendicular distance, this is going to be X minus X1. Okay. So writing the equation of equilibrium, Na into X here, Na into X minus Fa into Y minus 200 into X minus X1. 200 into X minus X1. Okay, equal to 0. Na I'll write as it is. X is 4 cos of theta, Y is 4 sin theta, X is 4 cos theta, X1 is 2 sin cos of theta. On substituting of Na Fa values, I get the equation. Open the brackets, we'll end up to this, wherein I get two equation with cos and sin alone. 2800 cos theta minus 800 sin theta equal to 0. I'll take out the hundreds out. 28 cos theta is 8 sin theta. Sin by cos is 28 by 8. So take tan of theta of 3.5. So theta you get 74.5. So this is the value of the inclination at the base at which I will avoid slipping. So these are the only two cases where I have to find one. In the previous case we found the P, and in this case we have to find the value theta. There can be another case wherein they'll give you the height or the base width, and you have to find the coefficient of friction mu. It's going to be same. We will be revolving around the three equations of equilibrium: Fx equal to 0, Fy equal to 0, and m equal to 0. Wherever required, we use Fy in condition and resubstitute in terms of each other to get the answer. This is your second numerical on the ladder friction. Thank you all.